So we talked on Friday about weak acids and the idea that because weak acids don't completely dissociate, we have to deal with them in terms of equilibrium. And I did an example and I talked about this, how you do the ice table. And in the end, you have Ka equals the concentration of hydronium times the concentration of the negative ion, the anion, divided by the concentration of the original weak acid. And if you look at the ice table, we have X, whatever this is, say it's 1 molar, minus a little x. So I'm just going to fill in numbers here. 1 molar, 0, 0, minus x, plus x, plus x. And you wind up with 1 molar minus x, and then x and x. And if you did a Kw or a Ka equation here, you would wind up with x squared over 1 molar minus x and because they're weak acids and they don't dissociate very much, they don't go very far to the right, whatever x is going to be much, much smaller than this original 1 molar concentration. And because of that, we can ignore the minus x, because 1 minus x is still going to be just about 1. Similar to somebody with a whole bunch of money, a billionaire, dropping $1 on the ground. They probably won't notice. They're missing $. Which winds up being Ka equals x squared, but the one of these two that we care the most about is the hydronium, because that's what makes it acidic. So we write hydronium squared over the concentration of the original weak acid. That makes our life easy. We don't have to deal with a quadratic equation. We can solve for hydronium, and we can find the pH of our weak acid. Questions about that? Okay. Something else that you might be asked to do for a weak acid is to find the pKa. Which is similar to the pH. But you take the negative log of the Ka for that acid. And it gives you a sense of the strength of the acid. So the smaller the Ka, the higher the pKa. And higher pKa's tell you it's less acidic. Lower pKa's tell you it's more acidic. Similar to pH. Questions about that? Okay, let's work these examples at the bottom. If ethanoic acid has a pKa of 4.74, what is its Ka? So we just said that pKa equals the negative log, so we have 4.74 equals the negative log of Ka, and we're supposed to find Ka. This is where you have to use your math skills. What's the opposite of a negative log, or the opposite of a log? Do you know? It's that button on your calculator. Nope, that's the natural log, but it's the 10 to the x. So, I don't know, on this calculator, it is above the log. So if I wanted to do this, I would take the negative, get rid of the negative, and then the Ka equals 10 to the negative 4.74. And I would get 1.81 times 10 to the negative fifth. Try that on your calculator if you have one right now. Make sure you know how to do it. So you multiply both sides by -1 to get rid of the negative on the right. And then you take the exponent. Make sense? Okay, if propanoic acid has a Ka of 1.38 times 10 to the negative fifth, what is its pKa? You just take the negative log of that. Which is the stronger acid, propanoic or ethanoic? Okay, so ethanoic had a Ka of 1.81 times 10 to the negative fifth. Propanoic has 1.38 times 10 to the negative fifth. This one dissociates more, so it produces more hydronium, so it's the stronger acid. It also, if we found the pKa of this one, it would be the pKa of the second one is 4.86. This one has a lower pKa, so it's a stronger acid. You can look at it both ways. The one with the higher Ka or the one with the lower pKa is the stronger acid. They should be the same. What is the pH of a 1 molar solution of ethanoic acid? Okay, so ethanoic acid I'm just going to write as HA in water dissociates to make hydronium and whatever the ethanoate ion is. HA starts out as 1, water 0, 0, minus X, plus X, plus X. 1 molar minus X, what we just decided is just 1 molar, X and X. I'm solving for hydronium, and my Ka is 1.81 times 10 to the negative fifth. So 1.81 times 10 to the negative fifth equals hydronium squared over 1. Take the square root of both sides. My hydronium concentration is 0.00425. And then to find the pH, I take the negative log of that. And I get 2.37 for a pH of that acid. You can see it doesn't match the pKa. pH is just the pH scale. 1 to 7, 7 to 14. Questions? Okay. that I want to talk about is number 6. Calculate the Ka of a solution of 0.250 molar of a weak acid with a pH of 5.11. Okay, so Ka equals hydronium squared over weak acid. They gave me weak acid, 0.250 molar. But they didn't give me hydronium. What did they give me that can help me find hydronium? The pH. So, to find the hydronium concentration, I take 10 to the negative pH. Right? The opposite. So, my hydronium concentration is 0.0, well, I'll put it in scientific notation, 7.76 times 10 to the negative 6. And then I could plug this in here, and this in here, and I could find the Ka. This is going to be important. Remember, if you're given the pH, you can find the hydronium concentration by going backwards. And you're going to need that maybe for your ice tables. Okay. The next thing is weak bases. We treat weak bases the exact same way we treat weak acids, except we have a Kb instead of a Ka. No surprise there. And instead of hydronium squared, it's hydroxide squared. And truly, the only weak base we talk about is ammonia, NH3. You can find pKbs the same way you can find pKas. You can use those to determine the strength, but that's really it. Questions? All right. All done.